Perth Linux Users Group, talking Linux and open source.
Okay, are we good? Right, so my name is James Henstridge. I work for Canonical. I'm on the desktop team, so the talk I'm giving today isn't quite about what I work on day to day, but it's something I'm interested in, and I think it should be interesting to you guys as well. So when I'm sort of talking here about building IoT projects. This is sort of Internet of Things, which may or may not like the term, but this is sort of what people usually use to refer to projects which you might build with a small Linux computer, sort of single-purpose small computer, which is sort of not a traditional desktop or server system. So it's the kind of thing where, like, projects built with a Raspberry Pi. That's a very good example of the type of thing I'm talking about. So if you are building up sort of a hobbyist IoT project, usually you'll start by buying a single board computer. Often Raspberry Pi is a very common one, but you can also get some cheap Intel x86 chips or various other systems. Often there will be, especially if it's an ARM system, you might sort of have a base Linux distribution provided by the board manufacturer, or at the minimum the kernel. You might need to make some changes to what the board manufacturer provided you, and then you write your application, you put it onto the storage and set it up to set your application to start when the system boots, and then you deploy it. So that's all pretty good for your first step. But the real question is, how do you keep one of these devices up to date? I mean, at one end you've got, how do you push out updates to your own code? Like, if you've just got one system, you might be able to just SSH in and copy it. But if you run 10 of these devices, or if you've set one up for your family or your friends or something, then you don't really want to be responsible for updating all those people's systems. And quite separate from your own code, there's the issue, how do you make sure that the base operating system and the kernel are all up to date? You might, so like the base Linux system, you might have a copy of OpenSSL, for instance, which is used extensively for a lot of software, but occasionally it's an old C code base, and occasionally there's security vulnerabilities come around. You don't really want to. Ideally, it should be someone else's job to make sure that stays up to date. And same thing for kernel vulnerabilities. Ideally, that should be. It'd be nice if someone else could handle that. So, Ubuntu Core is sort of a system which you can use which can help with these problems, to give you a system which will stay up to date. So, Ubuntu Core, it's based on the same package, on the same binaries you'll find on a traditional Ubuntu desktop, but it's stripped down, so it's just a minimal core. It's set up so that you update it transactionally. So when you update the system, you're going to get, rather than just doing it piecemeal, like installing a new systemd or installing a new libc or installing a new version of I don't know what other daemons you've got common, but rather than all of that, you upgrade all of them at once, and that upgrade is either going to completely succeed or completely fail, and you'll be on the current versions of those packages. The other thing it does is separates out applications from the operating system, so you can do a transactional update of the base system, which with the application staying intact, so you don't have like your own application code sitting in user bin mixed in with the base system. And similarly, you can do these transactional updates for your application code as well, because the way it's packaged, it'll be updated like that. It also has an automatic update system, so I think the default is every 4 hours. It's going to be checking for updated packages, and it will for what's installed on the system, and it will download those packages and install them. And if it's a kernel package or the base system package, it might schedule a reboot as well. So in essence, you've got a system which is, once it's set up, it's mostly hands-off, and it will just continue to run without user intervention. So to take advantage of all of this, you need to package your application in a way which can be used with Ubuntu Core. This uses the Snap packaging system. I think I've mentioned this in a previous plug talk, but I'm just going to go very briefly about how you can build up a Snap. The Snap packager on an Ubuntu Core system, everything on the system is packaged as a Snap, but it's also possible to install some application Snap packages on a traditional Ubuntu system, as well as various other Linux distributions, which means that you can do a lot of the development for your application just on a traditional Linux desktop, providing you're not dealing with parts of the application which depend on specific hardware for the device you're going to deploy on. So if you're just doing writing a network service or something, then you can easily test this locally. But if you're doing something which relies on the GPIO pins on a Raspberry Pi, for instance, then that might be a bit more difficult. But you can get a long way just testing things locally before you deploy. So the tool which you can use to package up an application as a Snap is called Snapcraft. So on an Ubuntu system, the Snap command will already be available, which can be used to install the rest of the tools. So you need to install Snapcraft and Multipass. You don't really need to. Multipass is just something which is used as part of the build tool chain, but you need it installed, but you don't really need to know much about how that works. Once that's set up, similar to if you're setting up a Git repository or something or other things, you can just run Snapcraft in it, which will configure a directory to run as a Snapcraft project. This will create a default snapcraft.yaml file which configures the build. You can then go through and edit that template and then perform a build. So for this talk, I'd been working on a very trivial web application just written in Go. This is, when I say trivial, I mean really trivial. Like all it does is displays something when you point your web browser at it. It doesn't really do anything else, but it's enough to sort of demonstrate demonstrate what you can do. So this is sort of the snapcraft.yaml file which I wrote for the project. So you've got the name of the package, a version string for the package. This is not quite the same as, the version number isn't treated quite the same as RPM or deb packages. It is purely for show, so you can publish multiple revisions of the snap which show the same version number. You could potentially have the version number going backwards. It's basically something which should mean something to the user. But yeah, so I just set this as 0.1 for my little application. Got a summary and description, and I set a license for the code, which will be visible in the package. Then the last 3 lines are just sort of describing how this particular application will run. Saying that it's built on top of Core 18 is saying that this is going to be running on top of the Ubuntu 18.04 based system. Grade stable just says that this is something which can be published to the stable channel when we publish the package. And strict confinement, this just says that the application will be running under AppArmor confinement, so that it sort of restricts what the application can do, so it won't interfere with the rest of the system. There's other versions for the confinement which you can use for snaps aimed at the desktop, but if you are building an Ubuntu Core system, your application needs to be able to run with strict confinement. So that's what I've done here. Then I can have an apps section which describes one or more entry points to the snap. In this case, I've just got this web app one which just runs a command bin/test jamesH web app, and I say that it's a daemon, which means that snapd will generate systemd unit files for it, and then the plugs bit lists a set of permissions which this particular entry point will run with. So in this case, I'm running it with the network plug, which means that the AppArmor policies will allow the executable to actually make network system calls and connect to the network, and network bind, saying that it will actually be able to bind to sockets rather than just connect to existing services, which is kind of important for a network server. And then the last section describes how we actually build things. So you can construct the package out of multiple parts if you're sort of bringing in multiple bits of source code and combining them into a single package. But here I've just got one part, which is I've taken source from the project itself, because you can easily pull code from an external Git repository to build that into your package as well. I've said I'm using the Go plugin, so that tells the Snapcraft tool to use the Go's default build system to build everything. So it turns out fairly simple. I did need to tell it to use add this build package as GCC, because in the default build environment, some Go applications don't need GCC installed, but the networked ones on Linux, they do need GCC. I don't know if that's possibly it'd be nice if we didn't need to do that, but I did to get this to up and run. So once that's all sorted out, I can build the package just by running Snapcraft, which will spin up a virtual machine running Ubuntu 18.04, and it'll make the code available to the virtual machine. It'll run the build and then copy back the build artifacts and package them up on my main system. And I'll end up with a .snap package. I can test that out locally by just running snap install -- dangerous. You need to use this dangerous flag in order to install local packages, because by default, the default action is to install stuff from the store, which have been published to the store. So, once your package is available in the store, you don't have to use the dangerous flag. But this is very useful when you're doing your initial development. So At this point, I sort of got a project which has got the Snapcraft.yaml. I checked it all into Git and pushed it up to GitHub. So the next stage is I want to have my automatic builds, because it's nice to sort of be. While it's good to sort of be building stuff, while I can sort of build everything locally, it'd be nice if I could get. If I could just have the builds happen automatically. So there is a service which we've got set up to handle this. In particular, this is good for building your snap for multiple architectures. Because while it's quite easy for me to build x86 snaps on my laptop, building something to run on an ARM system, for instance, is not quite as simple. So there are ways of doing the. I'm basically going over the simplest way which you can get this automatic build system set up. There are other ways of doing it which are a bit more complicated, but I think this is probably going to be the easiest you can do. So if you host your code on GitHub, you can use the system. It'll be set up so that every time you push something to master, the master branch on your repository, it'll trigger a build. The build will simultaneously happen on multiple architectures, and the package will be put into something called the edge channel. This is basically with snaps, when you're publishing snaps to the store, you can have multiple versions. So you can have the stable version, which you expect everyone to use. You might have beta releases. Edge is basically, you usually don't want to use the edge channel for other people's snaps because it could be anything. So like, again, if you're building the latest master version of something which has been uploaded to GitHub, then obviously that hasn't seen extensive testing. So, but it's very good for the automated builds and gives you a way to test these things. So there's a website, build.snapcraft.io, which lets you configure everything. It's fairly simple. I've got a few screenshots of the pages just setting things up. So you get this nice landing page. There's the green button in the bottom which asks you to, which you can use to start the setup process. You click that, it'll redirect you to GitHub to either log into your GitHub account or authorize the website to authorize Snapcraft.io to do various operations with your account. Once you've logged in, it'll give you a list of your builds. You can click the Add Repos button, which will then give you a list of every repository on GitHub which you've got access to. So you can then check a couple of those. So I've picked my sample web application, which added it to the list of automatic builds which I've got set up in the system. It says that it's not registered because I hadn't registered the application name on the store yet. So I could at that point I could sign in, where I'll be redirected to the Ubuntu One system, Ubuntu login system, where I can log in with my Ubuntu credentials to use that account, and come back. And at that point, I can put in a package name, and assuming no one else has taken the package name, I can register that, and at that point, I'm basically done. So I can then get a list of my builds. So there we've got our builds on x86, AMD 64. We've got both 32-bit and 64-bit ARM. And for some reason, we've also got S390 and PowerPC 64 Little Endian. I think that's mainly for some of the server stuff, but it just happens automatically and it passes. So I don't really care that I've got some S390 builds of my trivial web application. Oh, yep.
Just a quick question. Can you just say, I don't ever want an S390, just build ARM?
Yes, you can. sorry, you're repeating Pete's question is asking, can I limit what architectures my package builds on? Yes, it is possible to. Yes, it's possible to specify which architectures it should be built on, but at the same time, the worst that'll happen is it'll fail to build, and you'll get a red check mark, and it won't publish an S390 package. It's not going to hold up publication of your ARM or x86 packages. But anyway, so that's built and released all of those packages to the Edge channel, and nice and simple. When you've registered a package on the store, you can go to snapcraft.io, and again, logging in with your Ubuntu credentials, you can manage all of the registered packages you've got there. So you can update the descriptions, you can set an icon, add screenshots. You can also promote builds from Edge to beta to stable. You can also look at some simple metrics, so you can find out how many people have installed your application and where in the world they are. So it's that might not be particularly interesting if you're just building something for your own home, but if you think that your little project's good enough and you've written a blog post about it and you've said here's an image you can install onto a Raspberry Pi and go, you can then actually find out where people are actually running your application. So it's basically just simple anonymized metrics. It's not sort of going to identify individual users, but it's enough. It's the kind of thing which you're going to also see if you're publishing stuff on Android or iOS and those sort of systems. You can also add other people as collaborators on your project, which is useful once your application goes, if you sort of have other people who are going to work on systems with you. So yeah, that's just the simple listing configuration page for that simple web app. It's got some of the summary and description stuff, and the license information gets pulled from the package which I built, but you can then update it afterwards. I think it's also possible to upload translated summary and description, but I can't remember how. I don't know if that's sort of in progress or if it's actually there yet. But again, there's the releases tab, which I can see all of the revisions which have been uploaded to the store and which ones are available on each channel, and I've got the metrics, and yeah, and I think the settings stuff lets me allow other people to work on the project. So that's basically everything which you can run on your traditional Linux system. The next bit is Ubuntu Core itself. This is the system which we want to deploy our application onto. As I said earlier, an Ubuntu Core system is only snaps. So on your traditional Ubuntu system, most of the packages are installed as .deb packages, or Fedora systems, you've got RPMs. In this case, it's snaps, and the other big difference is most of your Ubuntu Core devices are only going to have a very small number of snaps. So I've got a base snap which provides an entire sort of root file system. So this has got your libc, it's got systemd, it's got, I think there's a Python 3 installation in there for managing some things. There's this is sort of the cut down system, which I think weighs in compressed at about 100 megabytes or something. You've got a kernel snap, which will have which is sort of kept separate from the base, and we've got a gadget snap, which describes how to put together a system, and then you've got application snaps, which will sit on top. So in general, a simple Ubuntu Core system might have for maybe 5 or 6 snaps on it, rather than hundreds or thousands of packages as you have on a traditional system. So that sort of gives you an idea of the granularity of your updates. So your base snap, this is the base file system. It's read-only. So there's a few locations which we make writable, but in general, most of the data there is going to be read-only. So, sorry, question?
Are these snaps something like the Docker file system?
So the question is what format snaps take. Snap packages are actually SquashFS file systems. So one of the benefits there is that they're already compressed, and you don't actually need to unpack them to install them. You can just ask the kernel to mount the package, and it's available.
Which sounds very much like the Docker.
I think I thought the Docker stuff is often tarballs, which are unpacked to make up the to configure containers.
No, the number of SquashFS layers.
Oh, right.
SquashFS layers, yeah.
Okay. Yeah. It's been a while since I looked at the specifics of Docker, but yeah. So yeah, it's going to be. I don't think we quite use the same layer. It's not sort of we're not using any UnionFS type things. It's similar but not similar but different, I guess. It does use some of the same kernel features as I used for container systems, because the container APIs in Linux, it's not a monolithic thing where you've got containers. There's things like virtualization of the mount namespaces, virtualization of the process IDs, and virtualization of user accounts, and various other things. And Docker might decide to virtualize a whole lot of things, a bunch of these namespaces to produce its containers. Snapd virtualizes a different set. So yeah, it's a nice thing about the Linux system, Linux containers API, because it's so flexible. But it also means if you're starting from zero, it's very complicated because there's not a single obvious solution on how to use all of the APIs together. Right. But yeah, again, so it's a SquashFS, so that's one of the reasons why it's read-only. There's generally going to be one base snap which is going to be used to boot the system. So this is going to be the snap which contains systemd, and that'll be where systemd is running from, and various other standard utilities. In general, there is only one version of the base which is used by all devices on the same architecture. So, and these are the Ubuntu bases are built and updated by Canonical. You wouldn't usually expect to rebuild those, but again, it is possible to have other bases. So, for instance, I did mention mount namespaces earlier. This sort of means that with mount namespaces, it means that when you've got multiple processes on a system, they can each have a view of a different root file system. So this sort of means that while the base system I built up might be running an Ubuntu 18.04 based Ubuntu Core system, I might have an application which was targeted at the earlier 16.04 base system. So I can have these two root file systems, base snaps, sitting on the system, and some of the applications might be running that one, and the other I might have other applications running the older libraries. This sort of is a way that we can sort of make sure that applications continue to run even but at the same time not restricting the base system from moving forward. So your kernel snaps, this contains a kernel plus the plus all the modules, plus any downloadable firmware corresponding to the devices which those modules use. Again, if you're coming from the x86 side, you might often think of having a single kernel which handles every device. If you then move to ARM, it's very common for different devices using the same instruction set to require different kernels. So that's one of the reasons why these are separated out from the base system. So, as a simple example, a Raspberry Pi 3 might need a different kernel to a Dragon board. One of them's got the Broadcom, the Raspberry Pi's got the Broadcom ARM chipset, and the Dragon board's got a Qualcomm one, and they just need to be booted up in a different way. And it would be nice if, I think there has been sort of effort to make sort of universal ARM kernels, but it's not there yet. So we have to support the systems people want to deploy onto. So again, a kernel snap will usually be used on a family of devices. So, and again, Canonical has produced a couple of these kernel snaps. So we've got ones for x86. In that case, it is a single kernel snap which will handle all of your standard PC hardware. And on the ARM side, we've got stuff for Dragon board and also Raspberry Pis, provided it's a Raspberry Pi 2 or above. That's because the original Raspberry Pi had an older ARM instruction set, which we don't support. And finally, we've also got the gadget snap, which describes how the system is put together. So this is what is the default partitioning for the system, how do you configure the bootloader, how do we configure any specific hardware. So if we've got the Raspberry Pi, a gadget snap for the Raspberry Pi, it's going to have configuration for GPIO pins, I2C, I2C, I mean, SPI and all these things. It's quite often that you'll have the gadget snap is going to be specific to a single device, especially on the ARM side, because I think we've got a single, we've got kernels which can support the Raspberry Pi 2 and Raspberry Pi 3, but we need separate gadget snaps to handle device tree, bootloader, and stuff for the individual models there. Then tying all those snaps together is a model assertion. This is basically just this describes how to put together a device, which is identifying the base, the kernel, and the gadget, and any applications which are required. For this talk, I'm going to ignore sort of how to create model assertions, because I want to go for the simplest way to get a running system. So Canonical again publishes some model assertions which are built from the kernels and gadgets which we publish. So it's possible to use the snap command to download these model assertions from the store, and then you can build up a system. So I've listed a command which I can use to download the Ubuntu Core 18 for AMD 64 model assertion. So it's basically just saying series equals 16. This is originally the idea was that this series would be updated each time we had an incompatible system, but we ended up not breaking compatibility going Ubuntu 16.04 to 18.04 for Core. This is sort of the multiple bases system I mentioned earlier. Again, brand ID is saying we're getting a model coming from Canonical, because again I can publish my own model assertions, which would then instead be use it linked to my account, and then the name of the model, which again here is Ubuntu Core 18 AMD 64, because nice and descriptive. And again, there are model assertions for 32-bit x86 and various Raspberry Pi models and Dragon board. So the next step would be to build up an Ubuntu image. So there is a command called Ubuntu image, which can build up your Ubuntu Core image. So again, that can be installed using Snap, and then I can invoke the Ubuntu image command telling it to build with the Snap argument tells it to build an Ubuntu Core system. I've said I want to sideload a couple of extra snaps, so this is going to pull that simple web application I published to the store, and then also using the model assertion, which I previously downloaded, and then dump the output in the image directory. And at that point, I've got something which I can then install onto a device. Just flash it onto an SD card or a thumb drive or whatever the boot device is for that system. Or, as I'm going to do in a bit, is boot a KVM virtual machine with that thing. I think in this case it would be pc.image, but it'll depend on the gadget Snap. I was going to give a demo for some of these things, so you'll probably see in a sec. So assuming everything works, it'll be good. So this is that simple web application which I'd set up. So again, I've got just a simple root handler which is going to handle everything, all of the web requests, and all it's doing is putting a simple hello response plus the path which is attached. I can then build this snap by just running Snapcraft, and assuming everything works and the internet's all working. So first it's starting up an Ubuntu 18.04 VM. So that's no, this is actually a KVM virtual machine. Launching. This should be doing something. Any minute now. Sorry, the question was, do you have to use KVM? So the original way we were building packages was often building locally. One of the issues there is, so I'm currently running the latest development release of Ubuntu. So I've got different libraries and everything. So any binaries which I produce on this system isn't necessarily going to line up exactly with. It isn't going to line up with what will be on the target system. Why is this taking so long? Can I kill this? Yeah, it is doing something over the internet, but well, anyway. Right. Well, anyway, we'll pretend that worked. So I've got the snap which we built earlier. So that's we did mention that this is a squashfs file. So again, it built. We've got the the binary there which is built, there's in the meta directory there's this contains some information about the package. So this will be the parts of that snapcraft.yaml which define the package. So this is like the name, the description, license, the apps section which described the entry points, and all those other bits. I can install that locally. So I was just using Polkit authentication to do the install, and now I've actually got a little web server running which was listening on port 8080. So where are we? So that's just running on my local system, not Ubuntu Core. So yeah, that's basically. So that's running in place. So that's still stuck. I'm assuming it's. Sorry, question.
What was it that you had it handle the route?
Yeah, so that was. I'd extended that little bit of that. I'd started off with a very simple bit of code. I was going to actually demo something in a sec, but. Let's see. So that's the really simple version without that extra code which we had there. So again, this is setting up an HTTP, registering a handler for the root directory with the built-in multiplexer, and then just telling it to listen on port 8080 forever and ever, and that's basically what that was doing. I'd been playing around a bit, just adding systemd socket activation, which would come in a sec. Anyway, so I can just remove that snap again, which just so that's gone, and now that service has been stopped. So when the package is installed, the systemd service gets installed and started. The removal process stops it and then uninstalls it. Sorry. Let's see. So we wanted to So I wanted to grab the model assertion. I'll just grab this thing just so that I don't have to type it out all again. So this is downloading the remote model assertion. So the model assertion here shows that this is one built by Canonical. We've got the Series 16, brand ID Canonical. The name says that this is an AMD64 system. It'll use the Core 18 as the base. It will use the PC gadget snap from the Core 18 track, and will use a PC kernel from the Core 18 track. And then there's a signature which just allows the system to, so that's a signature so that this can be verified against the public key registered with the store to say, yes, this actually did come from Canonical. This is sort of important when the model assertion might be allowing things like configuring user accounts or various other things that you want to limit. You want to be sure that there's some things you want to allow the person who's sort of configuring a device to do which other, and without sort of leaving leaving them completely open. Again, this is sort of allowing a manufacturer or the person who's developing the hobby project to do, rather than it doesn't specifically limit the person who owns the device. They've still got full access to their device, so they can do whatever they want. But this is sort of so the signature is important for limiting some of these other things to make sure that the integrity of that model assertion is correct, is okay. So again, I wanted to build up an Ubuntu image from that. So hopefully this one will work correctly. So this, the Ubuntu image command, it's going to download the snaps which were defined in the model assertion, and it's also going to, because I asked it to sideload my extra little web application, it's going to install that as well. So again, we've got the base system, we're downloading the kernel now. And it's downloading my little web application. Your question?
Yes, so the web application fetch is not installed on what you just were trying to do.
Right, so I described, so the question was whether that web application was coming from the local file I'd created or not. It is possible to list a file name rather than just a snap name, which is useful if you haven't got round to publishing things, but in this case, I have published that application, and it's available. It's available on the store already. So anyway, so we've now got an image. I told it to put the output in the image directory. So here we've got pc.image, which is it's got a this basically looks like just a normal x86 disk image with an MBR. Yep. Can just run fdisk on it to see that we've got a couple of partitions. So there's a bit of space for the BIOS bootloader as a first partition. We've got an EFI system partition after that. So that's got our. So this is basically we've got the PC Gadget Snap sort of installs two versions of the bootloader, so it'll boot on your traditional BIOS systems or newer EFI systems. And then we've got the main Linux file system. So I'm just trying to remember what the command was I was doing here. These are basically just they give some information about how it built the system. We can look at those. So this has basically told us what revisions of each of the snaps it installed, and what does snap.manifest. That's I don't honestly know the difference between those two things, but you could use these if you want to determine exactly what's inside the image file without unpacking it and taking a look. But yeah. So just use this image mounter, I think. So so this is the main. This is the main writable partition which we have in that image. It looks fairly empty. I thought that disk image mounter would also mount the EFI partition, but it didn't. Look in the system data. So in the end, it's a fairly empty looking system because this isn't the root file system which the Ubuntu Core system will be running. The root file system is the one sitting inside that Core 18 Snap. So in addition to the seeded to the snaps, we've also got assertions. This is basically signatures which are saying that these snaps, which are existing on the system to start with, those initial snaps, they have actually come from the store, and they've been signatures. Just say you need these signatures in order to make the snaps which start on the system that they'll be upgradable once the device is running. So again, that's basically it. So we've got our image. The next step would probably be to boot it up. So let's see if we can get this working.
What's the name of these images? Like, what are they called?
Sorry?
Or what's like, you have one of these sort of image files, what's like name? I mean, I know it's a bootable ISO, but
It's not an ISO. It's yeah.
yeah, that's right. I mean, and I guess my question is, it's been produced by the Ubuntu image command.
Yes.
Right? And what's it called? Like, what's your description of the name of the output of the Ubuntu?
Well, it's a disk image. So, like you might flash this thing, you might DD this thing directly onto a.
Can you just like DD it on something?
Yes.
Okay, so it's just a standard disk.
Yes. It's not install media. It's a system. Yeah, it's already yeah. Okay. So and I give this. Yeah, we'll create that. All right. So booting this up.
Fascinated that it's using Grub as a bootloader. It must be using Grub's support for Squash S to provide.
Yeah. So yes, this particular gadget does use because I'm running I built an x86. If you're building a Raspberry Pi Ubuntu Core image, you'll be using U-boot. I think all of the Ubuntu Core systems we've got are either set up using Grub or U-boot, but that covers a lot. Okay, so system's booted up. Ask me, do I want to configure it? I want to configure a network and administrator account. Let's see, ETH0, that looks good. It says that we've got DHCP. It's already configured via DHCP, so that's fine. If I was running this on a system with Wi-Fi, I'd be able to enter in network name, password, and all that information. Then it says who should be the administrator, give the email address. So. Now we see if everything works. And configuration is finished. So I can log in. Sorry, I shouldn't have done.
Is that how it gets the public keys by pulling
So yeah, so I've got my Ubuntu account. This is the same one which. And earlier I have to have an Ubuntu account to publish stuff to the store. there's a lot of different services on Ubuntu. We're using a single sign-on system, and this is shared. So one of the things you can do is register SSH public keys, which is the next thing I was just going to show you. So assuming everything works, I should be able to SSH into the system, unless I've configured things wrong. So. Yep, and I'm in. So, yeah, that's because I've got the SSH private key set up on the system. So this is a completely new system, and I just gave the email address, and I can securely log into the system. And at this point, I could pretty much ignore the I can ignore the console. So if I did sort of run this system headless, it would be fine. So yeah, again, this really doesn't look like that that empty file system which we saw when I mounted the image separately. So, but all those systems are installed. So I can see that the various snaps. The snaps which I'd asked for have been installed. Core 18, PC kernel, and this my little test web server. So I should be able to serve web pages from that system as well. So. Right, so that my web server is running. Okay, so the thing which we did sort of get a bit ahead when I was talking about that system deactivation, I had sort of been playing around. What do I do if I want? So I've deployed my Ubuntu Core system. I want to update it. So in this particular example, took this nice simple. My nice simple web server, and I want to configure it to use system socket activation. So this basically just involved changing how I replace that listen and serve forever command with stuff to get the socket from the systemd environment variables which are passed through. That was one half, and there were some corresponding changes to the snapcraft.yaml file. So I configured this bit sockets. So this configures says that my application should be listening on port 8080. I've actually already built this. I probably should have updated the version number so that it was obviously different. But so this.
Does your application pull that information from the snap metadata to know what port is showing?
So in this case, the snap metadata is used by. So the question was, does the application pull that information to do things itself? Not quite. In this case, the snap package manager will read the information from the YAML file, and it will generate the systemd unit files. So I'm sort of asking. I'm asking snapd to generate a systemd unit file, which will cause it to listen on port 8080. So let's see. This is just on the snapcraft.io site. I can look at my published snaps. I've got a bunch of stuff, but this is the one which we're interested in tonight. I can look at my releases. So I've got my original builds which are sitting in stable. So this is the version which is currently on the system. So in particular, you can see we've got revision 26. which corresponds to revision 26 there. If I can also just promote that build which I've currently got on Edge. Scroll down a bit. I can promote that to stable. So this is, I'm asking to promote on all architectures. I could also do it just on a couple if I had some reason to do so. So has that done it? Yes. So, yes, it already has. Sorry, Benjamin.
Does it give you any kind of like feedback or alerting? Like if you push an app to stable or something and it breaks for a bunch of people, is there anything in place that will let you know what's going on?
Well, your users can. Well, it depends. How do you define an application if an application is not working?
Say it crashes on load or something like that.
I don't know if we've got a crash reporter for external applications. That's something which we do want to set up, but I don't think that's there yet.
Sure.
In general, the idea of having these separate channels. The idea is to let you publish stuff on the store, and you can test out what it's going to look like when it's published to stable to catch these problems beforehand. So.
Basically, okay, you have your application that's published on the system, and in there it happens, and basically it's the code that runs goes out. You still would it be correct to say you've still got you've got 100,000 of these little systems out there in the wild. The application fails as it gets their updates, but I guess if you then updated a new update,
right.
would
Well,
the base system still be working to actually pull down the new update?
Yeah, well, again, there is this. So the question is, if there is an application error, is it going to damage the base system? So one of the ideas of Ubuntu Core was to separate out the applications from the base system. So this is making use of AppArmor, so AppArmor and SecComp and a couple of other things. So in general, even though I might be designing a single-purpose device and I've got this single application snap, the application is still confined to only write to its own files. So if it's misbehaving, chances are the rest of the system is still functional. So one of the things I could actually do is tell it to publish the old revision of the snap, make that the latest version on stable. So I mean, if something does go badly wrong, I can revert what I've just done here. And again, if you do have a large number of devices where the stability is important, I'd really recommend you make use of these extra channels. So latest, your edge, your beta, your candidate, your stable. So what I was going to check is, so I don't know if that's still getting these artifacts. I don't know what's happening there. Anyway, so if I waited 4 hours, I think, for the refresh timer to run, then my application would get updated. I can trigger it manually though, so let's see what happens here. All snaps are up to date. Yes, I think there is a setting which you can do for this. So why is this now? Oh, apply. Sorry. There's command line tools to do a lot of these, which is what I usually use. So I've been trying to sort of make use of the web thing as something which everyone here can take away and actually and use. Right. So our new snap is now the default. So again, snap refresh. Okay. Yeah, so, but again, one thing you'll notice here is that I published the new Snap, and Snap had already been uploaded. I made a change to what the latest version on the stable channel is. It's available instantly to all of the users. So again, we've got revision 33 there. It still says 0.1 because I didn't update the version number in the snapcraft.yaml, but yeah. Yeah, one of the things I think you're asking about, asking about systemd units. We can take a quick look at those. So again, we've got so this is an auto-generated unit file. It's got a. It says that it depends on this mount unit. This is basically set for when the system is booting up, because we don't want to try and start the web application until the squashfs file system containing the web application has been mounted on the system. So it says that it should start again after that mount unit and after we've got networking. And to start it, it runs this snap run test James H webapp.webapp. This makes sure that the AppArmor profiles are applied. So this is again one of the reasons why the unit files are automatically generated, so that the confinement gets enforced. So again, because I asked for asked for this application to be socket activated, we also generated another unit which sets up a listening on port 8080. So I believe web application. So currently my web app is inactive, but if I actually started the service automatically got started, and now it's running because systemd was listening on the port 8080, and on the first time someone tried to use it, the application started. So again, I've now got a fairly this gives me a fairly reliable web server, and it also means that if I was doing a couple of things, if I'd split my application up into a number of parts, so I might have a web front end plus some services which I want running all the time, can make sure that the web front end doesn't. We can delay the starting of that until someone actually tries to use it, so that the important things my device are doing, device does, can be set up can start up quickly. So again, this is basically a full running system, and it will. I could reboot the system, and it should come up again with the web server running. So let's just try hard rebooting the virtual machine to see what happens. All right, maybe it's not a hard reboot, but I'm running GNOME boxes, which it's GNOME boxes. It's basically just a front end for. It's a front end for KVM, and it basically just removes a lot of the options I don't care about, which you'd see in Virt Manager. But why is this not starting? Okay. I just wanted something which is nice and simple, which didn't sort of get in the way. Okay, so the system booted up, it got given the same, the DHCP server gave it the same IP address, so, and again, the web server is up and running, so again, everything is basically running. So yeah, I'm glad most of that demo worked, except for that running Snapcraft. That was pretty good. So yeah, the areas which you might want to look at moving forward, more than what I've done here, it's possible to create model assertions where you list application snaps which must be on the system. With the method of side loading, which I did, it's possible for me to remove that web server from that running system. If I want to decide that this particular device I'm building with Ubuntu Core must always have this application to be a valid system, I can set it in the model. I can make it required in the model assertion, and Snapd will not let you remove it from the system. One of the other things you can do with the model assertion is say that particular give permission for particular Ubuntu accounts to create users on the system. This allows you to create. There's a system where you can plug like a USB drive into your device or something, and if it's available when the system is booting, it can download a signed text file which will tell it to create a user account on the system. You can also use this similar system of putting a USB drive in to automatically configure the network. So, for instance, if you wanted to set up Wi-Fi and a particular user account on 20 systems, you could allow your user account, your Ubuntu single sign-on user account, to create users on the systems using this model assertion, build the Ubuntu image, flash it onto all your devices, boot them up with this, go around booting each of them up with this USB key to configure the network so you can connect to your Wi-Fi, and then you'll have these systems running and you don't have to do that initial configuration which you saw me do on this other system.
Does that config have to be signed? I'm thinking like Wi-Fi in particular is sort of...
Wi-Fi doesn't have to be signed. The Wi-Fi doesn't have to be signed, but creating user accounts, that does require a signature to do this automated thing. Because there's basically the system where I can just walk up to a device, plug a USB thumb drive into it, power cycle, and it will look for these auto load assertions from the system. So I can create one of the system user assertions saying that you should create a user account called James, which has this SSH public key, but ideally the signature that is there so that will only work on devices which have been configured to trust me, rather than other. So I can't just do it to other people's Ubuntu Core devices, which have been like if you've set up a router or something which is running Ubuntu Core or something. You might sort of also want to create a custom gadget snap. One of the things here. So for some of these permissions which I was using in this simple example, I was using network and network bind. These ones get automatically granted to any snap on the store because they are so common that if I want to install a web server, then obviously it's going to want to be able to use the network and stuff. There are some other services like being able to access GPIO pins on a Raspberry Pi or something that the application again needs to specifically ask for permission to use these. By default, they won't be connected up, so you need to wire these things up afterwards. It is possible in a gadget snap to provide to say that this particular application should be able to use GPIO. So I guess one example is if you're building up an irrigation system using Open Sprinkler, you might have a custom gadget snap which is saying that the Open Sprinkler Snap should be able to use the GPIO pins to talk to the solenoid control GPIO pins, but that's something which you obviously want on this Open Sprinkler device, but it might not be something you want to grant other devices which happen to install Open Sprinkler. And so again, it's granting extra permissions and stuff. So again, all of the gadget snaps from Canonical, they're available on GitHub, so it's quite easy to, I don't know what's going on with that display. It's getting some weird artifacts. So yeah, all of the gadget snaps and kernel snaps from Canonical, they're published on GitHub, so it's quite easy to fork them and make your changes, change the snap name, publish them to the store, and you can build your own images. So yeah, that's basically it. So has anyone got questions? Yes.
This is all well and good if you're happy letting anyone have your programs. What if you actually want to deploy something with some kind of security buffer around the average Joe getting
Yes.
applications for customers?
So the question is, what if you're not happy about publishing your snaps for the whole world to see? So there is a system we've got set up for brand stores. This basically lets you. This is still using Canonical's infrastructure for sending out snaps, but this allows you to have snaps which are published on the. You can limit what snaps are available on a particular brand store, and you can have snaps which are only published on a brand store. So I know there are some people who are using Ubuntu Core on robotics devices, and they have, like the gadget snaps and various other things, they only want them to be available for the brand store. And the brand, this is one of the things which some of those settings in the model assertion will determine which brand store the device will use. And it's possible to either have the brand store completely closed off, so you've got complete control over what is available to this device, or you can allow third parties to make their snaps available on that brand store, or you can make it completely open for other people to publish onto your store, or you can limit it to particular partners or whatever else. This is a paid service for the Ubuntu Core ecosystem, though. This is one of the ways that Canonical is making money out of the Ubuntu Core ecosystem. Does that suit?
Or is it like,
I honestly don't know the figures.
I literally can't find anyone who said they used it. I tried to find information about that, and it was contact us, which is
Yeah.
getting got you.
So I honestly don't have any idea. I mean, again, my interest on Ubuntu Core is sort of this is something I've been doing on some of my spare time projects on the weekends and stuff. Yeah.
Is the, like, to use the Ubuntu Core and the publishing system, is that a paid service only, or is it free software?
So the question was whether publishing on the Snap Store is free or a paid service. If you're willing to make your snaps available to the general public, as it doesn't have to be open source, but if you're willing to make them available to everyone on the store, there are no fees associated with publishing. So if you're looking on the desktop side, rather than these IoT embedded devices, there's a number of proprietary applications available on the Snap Store, like Skype, Slack, JetBrains IDE, Visual Studio Code, and various other things. We're not charging Microsoft and those other JetBrains and others to make those available because they're available to everyone. In this case, the brand store stuff is sort of paying for privacy and have control, higher level of control over the devices which you deploy. But again, everything which I've demonstrated here tonight is it has no cost. Right. I mean, again, yeah. 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 Everything I did tonight, you don't have to pay for. And I think if you're willing to make your if you're willing to publish stuff so that it can be installed on any Ubuntu Core or any system running Snap, then there is no fee associated with it. Any other questions?